do some more of this stuff. Actually, we're gonna open it all up so you can solve them all. Let's get it. So this is what we call the constant multiple rule. Let's just get a little closer to it. So if C is a constant and F is a differentiable function, when you take the derivative of a constant times a function, you just take that constant, rip it to the outside, just like you do with factoring, right? I mean, like, ignore that shit. Just take the C and multiply it by whatever you get from the derivative of the function. Here's an example. Just pop it up. Let's say f of x is equal to, now this is how this shitty they write this. You know what I mean? I actually have to do something different and I have to call it something, bear with me for just one moment. It's equal to some constant times f of x. That's kind of what they're writing. And they're saying, well, if you wanted to find g prime, you could just be like, just leave that c there and take the derivative. Now there's the math part of it. Let's get rid of it. Let's get to the solving. What the heck does this mean for us? You're like, dude, I'm just trying to pass a calculus class. Stop trying to, you want to be an engineer and you're like, stop teaching me math. I just need enough math to do physics and shit like that. All right, I'll shut up. Okay, let's look at this. Let's look at 4x cubed. Y is equal to 4x cubed. Let's take a derivative on it. Well, y prime, which you would look at this and you're like, dude, please just tell me that the 3 just falls to the front. We multiply it by the 4. Yep. And then we subtract 1. So the 4 stays there. So if the 3 falls to the front, but you still got that 4 times x to the, and we subtract 1 from 3, which is 2. Therefore, y prime is equal to 12x squared. That's the constant multiple rule. If you were in class, I'd probably do the proof for you. Try and do as many of them as I can, but you know what? Look at it in your book. It's a real simple one. There's not much to it. Let's go to our next rule. Look at that, just jumping right past. If f and g are both differentiable, if you take the derivative on a function plus another function, what this tells us, shit, just take a derivative on the f of x, take a derivative on g of x, the other one. Also, I'm doing it right now. I don't know. Put a minus down here, plus or minus. It works for both. It works for both. Let me give you an example. Say y is equal to, and let's start putting some constants. So 5x squared plus 3x minus 1. Shit, I gave you an f of x, a g of x, and an h of x there. There's one function, 2 functions, 3 functions. Man, I'm getting crazier than what the frickin' formulas are showing you. But the point is, you can go what we call term by term to go find the derivative. Cool. So we'll go y prime. There it goes. Now the 2 is going to fall to the front. And what's 2 times 5? That's 10. Now we're going to lose a power. 2 minus 1 is just 1. So we're not going to write anything. I mean, you could put the 1, but nah, don't do that. Now I ask you, we got 3 times x. The derivative of x is equal to 1. What's 3 times 1? 3. Or I would rather you just ask yourself, so you never lose this. You're like, what's the slope of the line for 3x? 3. Yeah, because that's what the derivative tells you. And now what's the slope of the flat line y is equal to negative 1? You know what I mean? What's the slope of that? The derivative of a constant is nothing. It goes away. You ever see a constant hanging out? Oh shit, I wrote it wrong. Derivative is still the same damn thing. It doesn't make any freaking difference what number you put back there, no matter how large you make it, how small you make it. If you take the derivative of a number, it is always going to be 0. So you could put like plus 0 in there if you wanted, but I'm just going to leave it alone. And write it in as such. And there we have an answer. Dope. Now this starts to open things up for us. Now we can take the derivative on any polynomial. Any polynomial, now we have the power to do it. So let's try a couple more. Let's just start throwing some stuff together. What do we want to do here? Let's get weird. Let's say f of x is equal to, I'm just going to start randomly writing some shit. Let's go 17x cubed minus, let's go 3 times the square root of x to the 7th. Let's go plus 5 to the 4th power minus, and let's go with 1 over x. Let's do that. Let's check that out. Let's see what our derivative is going to be. I think writing f of x again before we start might be a good idea. The 17x cubed. Well, that's not that big of a deal, but maybe we get this written that this is going to be x to the 7/2 power, 7/2, plus this number. I'm never going to solve that number because I don't give a shit what that number is. The derivative of a constant, because that's a constant. I don't care how big the number is. It's 0. And then we write it in as x to the negative first. Now this is what we call it's derivative ready. Top line, that's not really derivative ready. Second line, so you do a little bit of algebra first. I'll tell you, when you get to these, I'm an asshole. I'm an asshole when it comes to these problems. Like I like algebra. I like you to be good with them. One of my games when I make problems for y'all is I like you to have to do algebra before you ever hit it with a derivative. Now this isn't really algebra. This is just getting you ready. Just know that's a game I like to play. So f prime of x. 3 is going to fall to the front, and 3 times 17 is equal to 51. And we're going to lose power. No big deal. Now I'm going to write the 3, and the 7/2 is going to fall. 7/2 falls. And now we have to subtract 1 from 7/2. What's that? 7/2 minus 1? You mean 5/2? So we slap that 5/2 on in there. The derivative of a constant is absolutely frickin' nothing. I'm actually going to write that one in because I'm going to have to clean this up. And now with this, we're going to let our -1 fall to the front. And -1 times -1, that's a positive. And now we're going to subtract 1, -1 minus 1. That's x to the negative second. Now let me just clean this up because it's not simplified yet. Our 51x squared, and then minus our, what's that? 21x to the 5/2, 21 halves. Plus, and I'm going to write it out like this because it's just a good habit to stay in. You know what I mean? And let's go. I think that's a good solution right there. So you should be able to do this. This is where we really, for the rest of the freaking class when we take derivatives, this is where we want to get to. If we got to do algebra to make a polynomial, this isn't a polynomial because we have something, whatever. But this is, you want to get shit term by term so you can use the power rule. You want to use algebra to get there if you ever can. Factored sucks. Factored sucks. This is what I mean. You end up with a problem like this. Let's say h of x is equal to x squared minus 1 times 3x plus 4. Dude, we're going to learn tactics. Shit. The next section, you're going to learn how to do this for two functions being multiplied together. But even when you're in that session, don't do it. Do your freaking algebra. You want things to become a polynomial, which this is. This is factored. Power rule hates factored. FOIL. You know what I mean? Break that shit up and then go tackle it. I don't give a shit if you're in the power, or if you're in a section that's talking about products, which is called. Do your freaking algebra first. Make your life easier, because we will have tactics to deal with that. So we got 3x cubed plus our 4x squared. Are you kidding me? Are you kidding me? Minus 3x minus 4. Sorry for my handwriting, and I think this is a good solution. I think that's a pretty solid solution. Maybe not with the shaky next day alcoholic hands or anything, but yeah, and then that's how that's going to work. So your job at all times is to be able to go through these things, algebra the shit out of them, and then you can go and do something. Like if you got a square on something, what are you going to do? And we say you got this function, smiley face of x is equal to x squared minus 7, and this thing's raised to the second power. You're going to write that shit twice and you're going to FOIL it. If it's to the third power, you can do that. If it's to the 31st power, why don't you wait until we get to section 3.4? Then I'll teach you a trick. We'll make that shit real simple. So, but you got a square, you got a cube, something like that. That's telling you to just go like this and FOIL it out. All right, now I can't help it. I got to do it. So it's what, x to the 4th minus 14x squared plus 49. Sorry, just jumping through it. And now we'll take our smiley face of x, and we're going to be like, all right, smiley face prime of x. And we're taking a derivative, and we get what? 4x cubed. 2 times 14 is going to be We get that 28. We lose a power, and the derivative on a constant is absolutely freaking nothing. And there we have the derivative. See you in the next one.